Hey everybody, and welcome to ARE Live. I'm Chris Hopstock, Architect Education Specialist here at Black Spectacles, and your host for today's ARE Live. Today we're going to be joined by Black Spectacles virtual workshop instructor Hayley Pugh, who will be using the whiteboard and calculator to solve 5 complex math problems that you'll come across in PA, PPD, and PDD. We'll also offer a live Q&A session to answer any of your burning mathematical questions at the end of the episode. If you're joining us for the first time, Black Spectacles is the first ever NCARB approved online test prep provider for all 6 divisions of the ARE 5.0. Our test prep materials include video lectures, practice exams, quizzes, flashcards, and virtual workshops with a variety of membership options available either for individual architects, firms, AAA chapters, or schools. If you're curious about how you can get your whole firm on a membership and have your boss pay for it, go to blackspectacles.com and head to our firm pricing section. I'll share a link to that in the chat. We're also the first test prep provider to offer an ARE guarantee. If you use your expert membership to the fullest and you don't pass the ARE, we will pay for your retake. I'll share the link in the chat with more info on that as well. We're releasing new and improved study content all year long. We've already added section quizzes for all 6 divisions of the ARE and revamped our construction and evaluation materials. Up next is practice management. We just released over 100 brand new PCM flashcards, giving extra attention to firm financials and business structures. These flashcards are a sneak preview of our new PCM videos that we'll be releasing in the coming months. Black Spectacles is also expanding its offerings to help architects thrive throughout their entire careers beyond test prep and software learning. We'd like to extend an invitation to join Spectacular, the professional network built specifically for architecture and design. Create your free profile today to check out our job board, add your portfolio work, and explore our curated collection of projects from around the world. I just shared the link to sign up for Spectacular in the chat. Join us at our next ARE Live broadcast on November 17th, 2022, where we'll go over some of the most important concept of practice management as we review 5 questions that cover PCM knowledge and skills you'll need to pass the exam. We'll go over topics such as developing your office's human resources strategy, developing an appropriate legal structure, and responding to RFPs. We'll be sending out a mock exam link in the coming weeks so you can test your knowledge before going over your answers during the live broadcast. We'll also offer a live Q&A session that will answer any of your questions. I'll post the link to register in the chat box in your GoToWebinar control panel, or you can go to go.blackspectacles.com/ARE-live to sign up. Today, we'll be engaging exclusively in our online ARE community. If you think of any questions you'd like to ask Hayley in our Q&A session, be sure to post them there. You can either click the link that I just shared in the chat box or find it in the ARE Live section on our community homepage at community.blackspectacles.com. Everyone who posts in our thread today will be entered to win a free Black Spectacles t-shirt. So head over to community.blackspectacles.com and say hi. Don't forget to stay tuned until the end of the podcast to see if you won. I shared the link in the chat box and you can find it in the episode description if you're listening after the broadcast. We'll be sharing Hayley's screen during today's live, so we recommend watching the webinar to better see how Hayley works through these questions. This episode will be available in both podcast and video format after airing. So to get the full experience, you can watch the video on our website, blackspectacles.com, if you go to resources and then ARE Live podcast. Keep in mind that this may look a little different than on the actual exam, but hopefully it will give you an overview of how to use the whiteboard and the calculator. Without further ado, I'd like to welcome our special guest, Hayley Pugh. Hayley is an architect with Nelson Worldwide and is also a virtual workshop instructor for Black Spectacles. Before receiving her Master of Architecture from Louisiana State University and working closely with resiliency projects in their coastal sustainability studio, Hayley studied mathematics and art. So welcome back, Hayley. And with that, I'm going to hand it off to you for question 1.
Awesome. I'm super happy to be here. Thank you, Chris. So let's go ahead and get started with this first question. So we've got a map here. Okay, cool. So what I like to do when I'm answering questions is I like to scroll to the very bottom of the question, see what it's really asking. So when I go and do a read through of the question, I know what I'm looking for. So let's start at the end. So if the building is designed to the maximum footprint allowable and according to the client's program, What is the maximum allowable square footage of the building round to the nearest 100 square feet? Okay, so we know that we're going to be working with a maximum amount of square footage. Okay, cool. Okay, let's go up and take a look. All right, map, excellent. So refer to the exhibit. An architect is working for a client who wishes to develop lot 1, so this big guy here on the corner, into a multi-family residential project. The client's program calls for a 23-unit building, 3 units on the ground floor, and 4 units on the remaining floors. The following zoning information is available for the corner lots in the district. The floor area ratio, or the FAR, is 7.5. The front setback is none. The side setback is 20 feet along the shorter dimension of the lot, and side setbacks do not apply along lot lines that abut streets. And the rear yard needs to be 30 by 40 and cannot overlap a side yard. All right, so there's our lot. We've got a lot of information about where we can and can't build, so I'm gonna draw it. So let's start off with drawing our lot. So they have these really awesome tools over here where you can make shapes and change your border type and all sorts of stuff. So I'm gonna draw a rectangle. All right, so that's our lot. And I'm gonna go ahead and put a couple numbers in here just so I can kind of keep track of it. So 150. And so like we're just gonna assume that means feet. And then 102.17. All right, and so now let's take a look at our setbacks here. So front setback is none. So these front setbacks are gonna be the ones that are on the streets here. So these are gonna be able to build like all the way to the edge of the lot. All right, then it says the side setback is 20 feet along the shorter dimension of the lot. So this is the shorter dimension, so let's take off 20 feet there. So I'm gonna draw a little dash line here and boom. We'll label that 20 so we know how wide that is. Oops. Okay, so these tools are a little tricky and I can't get through without messing some of them up, but that's okay. Don't get frustrated. You can always right click and remove something if you accidentally drew something you didn't mean to. Pretty forgiving, all said. All right. Next, we need to have a rear yard. So the rear yard has to be 30 by 40 and it cannot overlap a side yard. So we have to make sure that this is its own thing, the side yard, and then we need to draw a 30 by 40 here. All right, so close enough. So we'll pipe in 30 by 40 so we know what we're doing. All right, so that's basically the buildable area is all of this in here. And so what we're going to do is we're going to very quickly calculate what this area is. And so we know it's going to be 150 minus 20 on this dimension. So we can do that in our heads, right? So that's 130. And then we know that this dimension is going to be 102.17. So what I would do is I would calculate the area of this rectangle and then subtract that rectangle out of it instead of doing something more complicated. So let's just do that real quickly. So 130 times 102.17. All right, so we got that number, and then we're going to subtract 30 times 40, which very quick mental math there is going to be 1200. So let's subtract 1200 from it. And that gives us the buildable area. And we'll go ahead and type this in here so we can keep track of it on a place other than our calculator. It's going to be 12,082.1. All right, so that's this polygon in here, right? 102 or 12,082.1. All right, so let's figure out here what we're doing in this buildable area. So let's go back to the question, and the question says that we need to build a 23-unit building. So 3 units on the ground floor and 4 units on the remaining floors. So if we've got 3 units on the ground floor, that means we have 20 units distributed on the rest of the floors, and 4 units per floor means 5 very quickly. So the ground floor and then 5 to cover the rest of them. So that's going to be a total of 6 floors, right? So, so we've got 6 floors. And if we know that this is our buildable area on each of those 6 floors, let's just take this number and multiply it by 6 and see what we get. So that looks like 72,492.6. And let's see, the FAR is a 7.5, but we did it in 6, so I think we're doing good there. So the only thing that we have to look at is the client's program, and it looks like the answer rounded off is going to be 72,000. We'll put this in the answer box here, 500.
That was great, Haley, and I really appreciate you using the not just the sketch tools available in the whiteboard, but these rectangular tools and changing the line types and thing. I think that's a pretty neat diagram, and I think you did it pretty quickly, so good job there. I just wanted to point out a couple of things about this question. This map that you see is a tax map. It's from New York City. You might see tax maps on the area, and there's no standard like graphic way that each municipality is going to draw their tax map. So don't get flustered if you see a map that looks a little different from what you're used to seeing. This particular map, it doesn't note the units, as Haley mentioned, but you can assume units on a tax map are always going to be in feet. The other thing I would say here is this question, which is pretty similar to one of NCARB's questions in their recently released practice exams, it requires you to consider the maximum size of the building based on the client's program and not necessarily based on the FAR. If you just use the FAR to answer this question, you'll come up with a higher number and you'll get the answer incorrect. So don't, I think this scenario is somewhat unrealistic in real life. If you're working with developers, they're most likely going to want to build the biggest building allowable, but don't apply that outside information to a question like this. If you've got specific information about what the client's looking for, and the question specifically asks you to consider that in the answer, go with that. Don't apply some outside information. With that, we're going to move on to question 2, and we're actually going to do this question a little bit differently. We've heard some feedback from you guys in the past that you want to see us go through questions faster, kind of like game speed on the ARE. So Haley's going to go through this question pretty quickly. No pressure, Haley. And then we're going to analyze it after the fact. So I just started my timer. Haley, go for it.
Oh gosh, okay. All right, so starting at the end, what should the client's budget be round to the nearest $1,000? Okay, proposed program, got a bunch of spaces here with a bunch of square footages. Refer to the exhibit. An architect is reviewing a proposed contract with a new client and wants to verify if their budget is in line with the architect's experience on recently completed projects. So the architect completed a municipal building for a neighboring town 2 years ago, and construction costs totaled $425 per square foot. That project, however, didn't contain a kitchen, which the architect estimates should cost $500 per square foot. The architect researched inflation and found that construction costs rose 3% per year since the project was completed. All right, so this looks to me like you've got 2 different things here. You've got all the stuff that they've done before that is going to be an inflated cost, and then you've got the kitchen, which got estimated separately. So if I were doing this, I would calculate the cost per square foot of everything but the kitchen, then account for inflation and add that to the cost estimate for the kitchen. So let's do it that way. So it's a cost per square foot. So let's go ahead and figure out how many square feet we have. So just use the calculator just to be super safe. 2,000 plus 1,000 plus 1,500 plus, oh, I missed one. No, I didn't. We're good. 750. I'm just going to keep going. Plus 250. And that gives us a total of 5,500 square feet that we're trying to estimate apart from the kitchen. And we know that's going to be $425 per square foot 2 years ago. So let's go ahead and multiply that by 425. And that gets us this. And so per year, we have to account for 3% inflation. So you can do this 2 different ways. I'm going to do this the fast way since it's just on the calculator and it's not going to take very long. If you were going to do this, never mind, I'll talk about that in a minute. Let's just do this. 1.03 for the first year times our answer, which was over here. This guy, you can use the history, it's pretty great. And then we've got this number for the first year, but it's 2 years, so we've got to add another one on. So we're going to multiply that times 1.03 again. It's got this really big number here, and so then we're going to add in the kitchen. So what we can do is we can add separately and just pull this number back here in a second. So what we're going to do is we're going to multiply the 500 square feet of the kitchen times the cost estimate of $500 per square foot of the kitchen. So that's the number for the kitchen. And so we are going to take this number and add it to, oh, I'm sorry, I'm using this wrong. So this number, and then add it to the less complicated 250,000. And that gives us this number, which is very long, and there aren't any commas, so it's a little hard to read sometimes. But then we need to round it to the nearest $1,000. So that looks to me like, let me put it over here in the answer box, 2730, and then 3 more zeros. Time.
I think you nailed it, and that was pretty quick. That's a really good example of how you can go through one of these math questions if you're comfortable and not really write everything out in the whiteboard using the calculator's history function. I think on the ARE, you'll need to sort of pick and choose which questions you're going to do that with just for the sake of time. And I think this question's a pretty good candidate for not writing anything out on the whiteboard. I will say, yeah, go ahead.
I completely agree. This one is just a bunch of multiplication and addition, so I feel like that's a good candidate as well, Chris.
Yeah, I will say, like, on its face, this question looks pretty simple. When you see a question like this, I would give it a second read. It's probably not as simple as just adding up the numbers in that chart, multiplying by 425 a square foot in this case, and then adding the kitchen to it. There's kind of a trick in this question, which is that you need to remove the kitchen from the program when you're doing the math based on your previous project, because you're going to calculate the kitchen out separately. So I guess the takeaway there is when you see a relatively simple looking question, make sure you sort of find what the trick is in it. You have anything else to add to this one, Hayley, before we move to the third one?
Yeah, there was a moment here when I had to multiply the inflation for every year. So another quick way you can do that, if you're comfortable using exponents, if you're not, I totally get it, but you could just take the 1.03 and raise it to whatever number of years power. And that's another way to do it, but you could also just do like I did and press it repeatedly on the calculator. That works too.
Yeah, I think that comes in handy if you're calculating for, say, 10 years or something of inflation. You might not want to waste the time on the exam and type out the number 10 different times. So if you're comfortable with it, I would certainly consider that trick. And I hope you guys appreciated us going through this one at game speed. If you did, let us know, and we're happy to do this for a question or two on future ARE Lives as well. With that, let's move on to question 3, and we're going to revert back to a little bit of a slower pace to really explain all of these concepts.
Okay, cool. So third question. So let's go to the bottom here. How many parking spaces should be provided? Okay, and so going back up to the top, I see a very familiar table to me. If it's not familiar to you, it might be a good one to take a peek at. This is table 1004.5, and it just has a whole bunch of information about occupant loads for different types of spaces. So refer to the exhibit. An architect is designing a new student housing building for a small college, and the building is going to contain the following: 50 dorm rooms at 200 square feet each, a dining hall that can accommodate 75% of the capacity of the dormitory, a 2,000 square foot kitchen, and a 3,965 square foot gym with a 500 square foot locker room. So the local zoning ordinance requires 1 parking space per 6 occupants as defined by the 2018 IBC table 1004.5, which they've conveniently handed us. All right, so how many parking spaces should be provided? So to me, this looks like we need to figure out how many occupants there are and then calculate the parking based on how many occupants we calculate for each type of space. So let's just start at the top and calculate the occupancy for all the program here. So 50 dorm rooms. So we need to figure out where dorms are going to fall on this occupancy table, and it's kind of right here where it says dormitories, right? And so that's going to be 50 gross. So if we have 200 square feet each and 50 of them, we need to figure out what our total square footage is going to be first. So that's going to be 200 square feet each, and then there's going to be 50 rooms. And that's going to very quickly equal 10,000, I think. Don't want to mess up my zeros in front of a whole bunch of people, so we're going to put it on the calculator. Yeah, 10,000. So it's going to be 10,000 total square feet. Okay, cool. So we know how many total square feet it is, and so now we are going to plug this into our table and see that we need to accommodate occupancy at a 50 gross. So that's going to be this 10,000 square feet divided by 50 to see how many occupants. And honestly, this math is right back here. It's just in reverse, so that's going to be 200 occupants here for the dorms. So I'm going to label this just to keep everything straight. So that's the dorm, that's the first one. And next we're going to look at the dining hall. Okay, so the dining hall can accommodate 75% of the capacity of the dormitory. Okay, so this is telling you straight up how many people it can accommodate, but it's based on another calculation. So what we're going to do is we're just going to steal our 200 occupants from the dorm. Occupants, and then we're just going to apply that percentage. So that's going to be times 0.75, and use your awesome little calculator down here. It's 200 times 0.75, and that's going to give us 150 occupants for the dining hall calculation. Sweet, so let's keep moving. So 2,000 square foot kitchen. So let's get the kitchen on here. So how's the kitchen calculated? So let's come over here. Kitchens, commercial, okay, that looks good to me. So 200 gross. So if we know the kitchen is 2,000 square feet, and then we're going to divide it by that 200 gross, and that's going to get us a nice little 10 occupants to calculate into that kitchen. All right, moving on. So let's do the gym. Okay, so the gym has a real weird number, but I'm pretty sure we can figure it out. So let's get the gym on here. And so let's see if we can find gyms up here. Let's see. So we've got a whole lot of stuff that we've got to sort through and figure out where the gym would be. And I hope I don't mess this up while I'm sitting here doing this. Business area, bowling centers, assembly, gaming floors, accessories, daycares. I swear I had this a minute ago. Chris, if you want to hop in and tell me what I'm missing, that would be great. Oh, exercise rooms. There it is. I knew I'd find it. All right, so exercise rooms are 50 gross. So what we're going to do is we're going to take this square footage again, 3965 square feet, and we're going to divide it by that exercise room number. It's kind of tricky about these is the names of what they call it in the program doesn't always match exactly to the table, so you've got to use your critical thinking a little bit there. So divided by 50. And this one's a weird one, so I'm definitely going to use my calculator. And that's going to give us 79.3. So 79.3 is more than 79, so we're going to err on the side of conservative error here. So we're going to call that 80 occupants and round up. All right, last we've got the locker room. And so the locker room is 500 square feet. And let's see how we calculate that one. Oh, well, that one's easy. It specifically says locker room, so that one's going to be 50. Cool. So divided by 50, and that's another easy mental math there, and that's going to give us 10 occupants. Oops. Okay, great. All right, so we've got all of the occupancy numbers here. And so now what we need to do is figure out the total occupancy and then figure out the parking based on the total occupancy. So I'm just going to use the calculator for the rest of this question. So we're going to take all of these individually calculated occupancies and add them up. So 200 plus 150 plus 10 plus 80 plus another 10. All right, so that gives us a total of 450 occupants. And since we know that we need one parking space for every 6 occupants, we're just going to take this total number and we're going to divide it by 6. And that gives us 75 parking spaces that we need.
I'm really glad you tripped up on the gym versus exercise room, because that's a really good point to make, is that you need to become familiar with this table and the words that are used in this table. I think also when you see student housing here, you need to know that that means dormitories. I mean, the first bullet point uses the word dorm, so that's a clue there, but you definitely need to be familiar with this table and sort of comfortable with the verbiage that might be used to describe some of these spaces that might be different from what's actually in the table. The other thing here that we obviously should talk about is the rounding for the gym. I would say for the ARE, I would always err on the side of caution, just like Hayley did, and round any occupant loads up. Even if it's 79.01, I would round it up. I know in reality, if you're working on this with a building code official and it comes out to a number like that, maybe they'll let you round down. But for the sake of the ARE, I would always round occupant load up. It's the more conservative approach. It doesn't, one occupant usually doesn't have a huge effect on things when you're designing a building. So it's just best practice to do that. I think otherwise this is a relatively straightforward multi-step math problem. But I would certainly recommend, at least for PPD and PDD and maybe even PA, just getting familiar with this building code table and making sure that you're comfortable using it on the ARE.
Yeah, and
So
don't do a podcast and forget how to read a table. So
that's another good point. I think with that we can move on to question 4.
awesome. Okay, let me get my calculator cleared out. I've got a new whiteboard page, and let's check out this question. So at the very bottom of here it says, which product offers the lowest cost over a 25-year lifespan? We've got 4 choices here. All right, so let's go back up to the top. So it looks like we've got a table. The table has a material cost, an installation cost, and a life expectancy. We've got a whole bunch of different things here, but it looks like these 4 match these 4. So it looks like I don't have any extra information, so that's good. All right, so refer to the exhibit. An architect is comparing 4 different options for waterproofing of an exterior wall system. The total wall area to be covered is 4,000 square feet. The architect wants to evaluate the 4 options based on a 25-year life expectancy to determine the most cost-effective product. So which product offers the lowest cost over a 25-year lifespan? All right, so it sounds like we're going to be calculating the cost of each of these and then comparing them to each other and figuring out which one is the cheapest. Right away, I can see in this table that they're all kind of calculated differently and they don't all have the same life expectancy either. So what we're going to have to do is for each one of them, we're going to have to figure out how much it costs over 25 years. And that might get a little complicated for some of these, but I think we can handle it. All right, so let's just start off with Ultraflex. I always like to write things over here on the whiteboard and keep up with it when it's more than just like a very straightforward question. It has a tendency for me to trip up less if I have it all typed out. All right, so let's see how Ultraflex is calculated. Ultraflex is calculated material costs, $450 per square foot, $4,000 for installation, and it's going to last 15 years. All right, so I think the way we're going to do is we're going to calculate the material costs, add it to the installation costs, and then see how much that would be for 25 years, not just the 15. All right, so that first part is going to be $450 per square foot. So in my mind, I'm thinking 450 times the 4,000 square feet that we're covering. And that's going to end up being 4,000 times 4.5. That's going to be $18,000 for the first part. Okay, so that's the material cost, and we've got an installation cost too. So we're going to add 4,000 to this number. So that's going to be add 4,000 to that. So material and installation is going to be 22,000 for this. Oops, wrong box. Okay, so there we go. All right, so that's for 15 years, but we're wanting to know how much it's going to be for 25 years. And so in order to do this, we need to multiply this by how many we're wanting versus how much it's going to give us. So we're going to multiply by, hey, we need 25 years out of this, but it's only showing us 15. So now we're going to be able to get that ratio of how much it's actually going to cost for that extra. So we're going to take this 22,000 that I accidentally already have in my calculator here and multiply it by 25 and divide it by 15. And so that's going to give us a 36,666, etc. dollars. So that looks good to me as far as like how much that's going to cost. So let's go ahead and put that number in. And then let's move on to the next one. So let's see, XL air barrier is our next one. Oops. Okay, so XL air barrier gave us a flat number for the material cost, so that's kind of nice. We can just put that down without having to calculate anything. And then we've got $3,000 for the installation. So that's going to be 15,000 plus 3,000. Oops, that's not the right symbol at all. Okay. 3,000, and that's going to give us 18,000 for that. But this is another one of those where it's not going to last the full 25. So we need to take that 18,000 and multiply it times another ratio. So this time we need 25 out of it. It's only given us 20. And so what does that give us? So let's go ahead and do this one down here on the calculator. 18,000 times 25. And then we're going to divide that by the 20 years that it gives us. And that number is $22,500, which so far this is our winner. This is cheaper than the Ultraflex, so it's the front runner right now for our correct answer. So let's keep going down this table. Leak guard, 5,000. What a great name for a material, leak guard 5,000. All right, so oh boy, this one's given to us in square yards. So we've been calculating everything else per square foot. So we probably need to get this one on board with our square foot metric that we've been using. So this is probably something you know. There's 9 square feet in a square yard. So we're just very quickly going to divide this 27 by 9. And so we know that this one is $3 per square foot. I don't need to put that in a calculator. So this one is $3 per square foot. So let's get that plugged in over here and times our 4,000 square feet. And that's going to be equal to $12,000 for the material. And then we have installation cost, which is included. Hold up, that's great. So since it's included, we don't have to add another thing here. So we can go ahead and go to our end calculation where we compare its life expectancy versus the life expectancy that we need. So we're going to take that 12,000 and we need 25 out of it, and it's giving us 15. And we're going to do that math in the calculator. So 12,000 times 25. And then we're going to divide that by 15, and we're going to get 20,000. Ooh, we've got a new front runner here. Okay, so that Leak Guard 5,000 is looking a little bit better than some of those other ones. All right, so let's go down to our last one and see how it compares. So Air Max, Air, and Moisture Bear. That's too much to write, so I'm just going to write Air Max. All right. So it's $4 per square foot and $1.50 per square foot installation, and then the life expectancy is 25 years. So you could do this a couple different ways because these are both calculating square foot things. You know that the material and the installation are going to calculate off the same square footage. So what I would do is I would add them first and then multiply times the square footage. So this is $4 a square foot for the material, and then add that to $1.50 per square foot for the installation, and then multiply that times your 4,000 square feet. And we'll just put all that in the calculator real quick. So 4 plus 1.5 is 5.5, and then times 4,000, and that's going to be 22,000. So now what we can do is we can look at this bottom line number for each of them, and it looks like the Leak Guard 5000, super neat name, is going to be our winner.
I really appreciate that you appreciated the names of these because I came up with them on the fly and didn't want to use real product names. So yeah, that was a fun part of writing this question. I would say this is pretty common on the NCARB exams from what I've seen, the mixing and matching of units. I would get really comfortable with that and keeping the units straight. I would also obviously make sure I know how to convert square yards to square feet. Obviously, the tricky part of this question is accounting for the life expectancy of each of these materials. So if you come across a question like this on the exam and you don't know how to do it right off the bat, I would consider maybe marking this for review and answering it later. I think then you can sort of reset, understand how much time you have left per question after you've gone through the ones that you know, and maybe feel more comfortable devoting a little more time to this question. With that sort of approach, maybe you'll end up with 5 or 6 minutes to answer this question, and you can kind of go through the logic in your head and figure out what makes the most sense, checking your answers along the way. So that's a strategy I would use for not just math-based questions, but a lot of questions that you might not know right off the bat on the ARI. We did have a question about this in the community that I usually wait till the end for, but I figured we could just answer it now since we're on it. Somebody asked, I believe we multiply by the number of times we're going to install the materials since the costs are material and installation costs. So for example, I would just multiply the first one by 2 since we're installing it twice over the 25-year lifespan, not 1.6. What do you think about that, Hayley?
I don't think that's like a bad initial knee-jerk reaction, but the whole idea is that would give us a total life expectancy of 30 years. And so I totally get how you're saying that, well, you're going to install it, so it's going to cost this. But I think it's really important to understand that, in reality, yes, but you would get more than 25 years out of it if you factored in the total cost. And so since we're not wanting to know how much it costs, period, in 25 years to install it. We're talking about like what's more cost effective. So it actually becomes like a percentage of what it would be. So like when it comes to calculating like just lifespans of things, you always want to take into consideration those percentages instead of strictly speaking, this is how much it would cost. It's always going to be a percentage unless it's spot on with that life expectancy like that last one was.
Yeah, I agree with that. I would say I think a helpful tip when you're having one of these sort of dilemmas on a question is to put it into a little bit more of extreme terms, right? Think about if one of these life expectancies was 24.99 years and one of them was 25. It would be sort of unfair to multiply that 24.99 life expectancy by 2 when the 25 years is only multiplied by 1, right? You're going to replace that 25-year life expectancy a day later than year 25 theoretically. So I think if you put it into those extreme terms, you realize what the right direction to go in is. And I would recommend that sort of a logical thought process when you're having one of these dilemmas on the exam.
I super love that. I wouldn't have thought about it that way, but like you're totally right. If thinking about it like way off like that is a super great way to think about it.
Yeah. Let's move on to the next one.
Okay, so got my next question pulled up. Gonna get a new canvas on my whiteboard and gonna clear out my calculator and let's get started with the question. So let's go down to the bottom here. What is the composite R value of the wall? Okay, sorry about that. It says an architect is reviewing their project for energy code compliance and wants to evaluate the composite R value of the typical zero lot line exterior wall assembly for their multifamily residential building. After reviewing the specifications, they've compiled the following information. Stucco has an R value of 0.8. Gypboard has a U value of 2.0. Uh-oh, getting tricky. Bad insulation has an R value of 3 per inch. Wood studs have a U value of 0.25, and windows have a U value of 0.4. The wall contains gypsum board on both sides of the structure, which is framed with 2x6 dimensional lumber. The architect estimates that this wall is 20% framing. What is the composite R value of the wall? Okay, so this question is really fun because you have to think about several different things. So the way I would think about it is I would think about what my wall looks like. So I would start off by just thinking about how this wall is going to look. And so we know that this wall has stucco on the outside, and we know it's got a layer of gyp, right? And then we know we have this the framing, right, which also has the insulation in it. So we've got the frame and insulation in that middle layer. And then we've got another layer of gypboard. And so when I'm thinking about a wall, I like to think about what it looks like from either the inside out or the outside in so I don't miss anything. Oh no, did I just lose it? Oh no, that's awful. Okay, I'm going to type it real quick while I'm talking.
I
So,
think I think if you type redo, you might get it back, but you can try it. Maybe not.
oh, that's okay. Oh, no. Okay. Well, all right. That's
Sorry
okay.
about that.
No, this is great. This tool isn't always super intuitive, so thanks for bearing with me. So anyway, we've got stucco, gyp, then we've got the framing and insulation, and then we've got another layer of gyp. So the way what we need to do this is we need to calculate the R value of each component, and then we're going to add them together and get the R value of everything. So let's just start from the outside and let's get our stucco value. So the stucco is maybe like the only thing that's straightforward about this question. The R value is 0.8. So let's go ahead and get our stucco in here as R of 0.8. Okay, so next what we can do is I like to think about this in layers. So our next layer is the gypboard. So now we need to calculate what the gypboard is in this layer. So it gave us a U value, and if you can dig into your architect's brain there, that's just the inverse of the R value. So this is going to be 1/2 is going to be the R value there. So that's going to equal 0.5 just quickly as a decimal. Now we have that layer that has both the framing and the insulation. This one's going to get a little bit more complicated because we have a value of R per inch here. We know how big our dimensional lumber is, and then we know what percentage of that layer is framing versus how much of it is insulation. So the way that I would approach this is I would calculate the wood stud R value, and I would calculate the batt insulation R value, and then I would assign them their percentages for this layer. All right, so let's go ahead and do the part of the wood studs. That sounds fun to me. So the wood studs are going to be, okay, so it has to do with 0.25. So that's great. So we know that they're 0.25. Pick the easy one first. And then we know insulation is going to be 3 per inch. Okay, so, oh, nope, that's 1/0.25. See, I messed up there, but that's okay. So 1 divided by 0.25 is going to equal 4 before we add our, oh my God, are you serious? Okay, redo. Okay, sorry, I'm doing my best here. Okay, so so this is equal to 4, okay, before we give them their percentages. The insulation is going to be 3 per inch for the R value. So we know it's 3 per inch. And this is where you have to dig a little bit and know that 2x6 dimensional lumber is not 6 inches thick, right? That's going to be 5.5 inches. So it's going to be 3 per inch times 5.5 inches, and that's going to give us 16.5. Okay, so these are the individual components, how much they are, but now we need to think about what percentage of each is happening. So we know that the wood studs are going to make up about 20% of this layer. So we're going to multiply this 4 number times 0.2. And then that will give us 0.8. So that's the stud portion of this layer. And now the insulation is 80%. So we're going to multiply 16.5 times 0.8. So 16.5 times 0.8, and that's going to be 13.2. And so this layer in the middle here is going to be for a total of 14. And then we have another layer of gyp on the inside, and we calculated that one previously, and that one is 0.5. Okay, so now we have a few numbers here to work with. We've got that outside, we've got the gyp layer, we've got the framing and insulation, and then we've got another layer of gyp. So we're just going to add all these together, and we're going to have the R value of our wall. So 0.8 plus 0.5 plus 14 plus 0.5. And that gives us an answer of 15.8.
Yeah, I think one of the tricky things about this question is you might forget to add the second gypsum board. So I think it's really helpful to write this out. And if you have the extra time, maybe even draw what this wall looks like while you're answering this question so that you don't miss that 0.5 and get marked incorrect. I think a couple of other things about this question, the dimensional lumber. I think you're unlikely to see a question on the exam that's going to ask you specifically, you know, what's the actual size of a 2x6 piece of lumber. That's a really basic like question that just requires you to remember a piece of information. But that type of information does come up in these more complicated questions where you need to apply that knowledge of a material to answer, in this case, a question about R values. I could also imagine a question maybe asking about costs, and you need to understand how to read the size of a steel beam and understand the weight of it based on the nomenclature used for wide flange steel beams, for example. So don't overlook the knowledge that you need about these materials on these exams just because you don't expect to get asked a really straightforward question about them. The other thing here is we included a U value for windows in this question, which is irrelevant to the ultimate answer here. You might be tempted to see that piece of information and kind of try to fit it into the answer to your question just because it's provided, but I would caution against that. I think you're going to see some extraneous information on the exam, and just be confident that you know you don't need to use it. For this one, you could go down a line of thought seeing that there's a 0 lot line exterior wall assembly, and you know that there's a maximum allowable openings in a wall like that, and sort of apply that information like that. But that would really be taking a step too far, in my opinion, and applying extra information that is not presented in the question. And the last thing about this question that we saw in a couple of other ones is the mixed units, R value versus U value. They're super easy to get confused and to mess up. So it's really important to keep your units straight. You obviously could answer this whole question in U value if you want, and then convert at the end. I find that more confusing since you're working with more decimals than whole numbers, but it's really up to you and what you're most used to and most comfortable with. Let's see, we had a question here on this one for question 5. Why wasn't the air film layer on the interior and exterior added? Hayley, do you have any thoughts on that one?
Well, I would definitely say that usually questions will give you the information you need to answer it. And so because we weren't given a value for that, it's very highly unlikely we should account for it.
Yeah, I agree. There's in real life you would account for that, and that's the thing about this exam versus reality is in real life you can just go look up what the U value or R value of that piece of that material is and include it in your calculation. You can do that. That's kind of the whole point of what you're doing as an architect. You're finding information and applying it to your problem, and you need to step out of that line of thinking when you sit for this exam, and I guess when you're studying for it as well, because you need to really only use the information that you're provided with. Now, if this was a case study question and you had a whole chart of R and U values and that information was in the chart, I would certainly include it if the question specifically noted there was an air barrier in the wall assembly. I would include it, but in this standalone discrete question, I would not go about applying additional information.
Yeah, and I could totally see how there would be a question on one of these exams where they would refer you to their construction documents, a wall section, and then you'd have to look at the wall section and then compare it to a table of R or U values and then calculate it. So they would test your knowledge of both looking and interpreting a drawing and also being able to read a table. So there's lots of different applications that I could totally see happening on the ARE.
Yeah, for sure. Let's take it back. We're going to move into questions and answers now in our community, from our community. Let's take it back to question 1, and I will do my best to go in order so we don't get confused here. The question is, since the first question is asking for the maximum, quote, allowable square footage, shouldn't we only account for the FAR? Had the question asked for the total square footage, then the setbacks and number of stories would come into account. What I would say about this one is I agree the wording of this question is confusing, and I assure you that I'm not trying to be confusing just for the sake of it. There's a question on the NCARB PA exam, it's question number 3, that has a really similar concept to it, where the answer requires you to take into account what the client wants to build and not just what the FAR would allow. And like I said when we were talking about this question, I agree that's not reality. Most, if not all, developers are going to build the biggest building possible. But like I just said, you've got to sort of step out of that mindset on the exam itself and really answer the question. So reading this question super specifically and slowly, it's if the building is designed to the maximum footprint allowable and according to the client's program, what's the maximum allowable square footage of the building? So the according to the client's program that Hayley highlighted there is really the operative term. And perhaps this could have asked what's the resultant square footage of the building. Again, I included maximum allowable because that's the wording that's used on the NCARB exam. And again, you know, we really study everything that NCARB puts out there so that we understand how they're asking questions and we can best prepare you all for this exam. And that's where this question came from. I do think it's tricky, but we would be doing you all a disservice if we didn't go over these types of questions to prepare you for them. So with that, I think, can you go to question 2 for a second? I want to see, I don't think we had any questions about this one, so let's move on to number 3. The question is, and I'll pass this one over to you, Hayley, how would you know to use exercise room versus assembly space without fixed seating factor? At my firm, we calculate gyms with the assembly without fixed seating factor. Is this just an NCARB thing?
I would say here that this, I totally get what you're saying, but the whole idea is that people are exercising in these rooms and it's not all meant for people assembling. And so I would say that I think that exercise room is maybe just a good way to think about this. Another way this question might have been worded to avoid that would have been a square foot workout facility or something like that, so there wasn't an implied assembly type nature to it. So I mean, gym can mean a whole host of things, right? It can mean like a basketball court with a whole bunch of bleachers. It could mean any number of things. But in this situation, we went with the exercise rooms. But I think if you specifically are more familiar with the program outside of a single word, you could be better able to make that judgment call. So it very well could be an assembly space in some situations. But as for what we were given in this very brief word gym, and we had an exercise room as an option, I think that was a good choice.
Yeah, I agree with that, and I think this person might be practicing in New York City because that is how you do it in New York City. It's 15 net occupants per square foot in a gym. But I agree with what you said, Hayley. I think the closest thing here to the word gym is exercise room, and I would say that I think there would be better clues if you needed to use the assembly portion of it on an NCARB question. I think it's kind of unfair if they don't give you that information or hint you better to use the assembly designation. So I agree. This one's a little tricky, but I think the best answer here is certainly exercise room for that one.
That was a great question.
Yeah, thanks. Let's see here. We can move on to, I believe, question 4. What was was it question 2 where we were talking about adding the inflation?
Yes.
Yes, right. So sorry, going around here, but somebody asked, I'm terrible with percentages. So for question 2, when multiplying the yearly 3% inflation, why do we multiply by 1.03 and not 0.03? And then secondly, this is a related question, wouldn't the inflation rate of 2 years be 0.06, sorry.
Okay, both are super awesome questions, so thank you for those questions. So first of all, when it has to do with a 3%, yeah, you can multiply it times 0.03 and that will give you the 3%, but then you have to add it back to the original amount. And so if you instead multiply times 1.03 instead of just 0.03, you don't have to add it again. So that's why I do 1.03. It saves me an addition step.
That actually came up on the last episode that you joined us for, which was July of this year. So if anybody wants to listen to that one on our website, you can certainly do so. And that's a great tip. That saves you one step, like Hayley said. If you come across 2 or 3 questions per exam that require you to do that, maybe you'll save a whole minute or something. And that might not sound like a lot, but I think every second is pretty valuable. I would also say, just in general, throughout your life, it's just faster to multiply by 1.03, and that's just sort of the way I do it. And then the second question there was, wouldn't the inflation rate for 2 years be 0.06?
Okay, so the reason it wouldn't be 0.06 is because it inflates on top of how it had already inflated. So the way that math works is that you have how much it costs times 1.03 for the first year, and then you get the amount that it costs after that first year of inflation. And then if it's going to inflate again, you have to take that number and then multiply it times 1.03 again. So it's not additive, it's multiplicative, if that makes sense.
Yeah, that math applies to a lot of things. If you're trying to figure out, how well your retirement portfolio is going to look in 5-10 years, and you think it's going to make 5-8% or something, you can't just add those percentages together and multiply. You need to multiply by the percentage each time, because it's compounding inflation or compounding gains if you're talking about the stock market. Let's see. Let's go to the question with the occupancy load chart. Yep. And Hayley, if you could answer this one, somebody's asking if you can clarify the difference between net and gross square footage for the occupant load.
I'm awful at this. Okay, so so I think that has to do with where you determine the square footage as far as the wall. So like I'm not going to be able to get this right. I'm being put on the spot about something that I have to look up every time. I'm going to be real with you. I have to look this up every time.
Yeah, no worries. It is confusing. Net square footage, like let's just look at some examples here. Classroom is 20 net. I think daycare is 35 net. Bowling centers. It's all these kinds of spaces where the activity that you're doing in that space doesn't take up the whole space. So it would be kind of unfair to apply, let's use the bowling center, for example. It would be kind of unfair to apply that really low number of occupants per square foot to the entire facility. You've got the area where like you go get the bowling balls, you've got the front desk, all the, circulation space. So you apply that net square footage just to the areas where you're actually using the space for its intended purpose. So I think that's the best way to think about it. And gross square footage is exactly the way we did it in this question, where you simply just apply the square footage of the space to the factor in this table and call it a day. So without providing like a floor plan or some more information to this question for you to figure out the net square footage of the space, you wouldn't be able to answer the question. That's why I chose all spaces that had a gross factor here. Just checking if we've got any other questions, and I don't think we do, so we can wrap it up. That's it for today. Join us at our next ARE Live broadcast on November 17th, 2022, where we'll go over some of the most important concepts of practice management as we review 5 questions that cover PCM knowledge and skills you'll need to pass the exam. We'll go over topics such as developing your office's human resource strategy, determining an appropriate legal structure, and responding to RFPs. We'll be sending out a mock exam link in the coming weeks so you can test your knowledge before going over the answers during the live broadcast. We will also offer a live Q&A session to answer any of your questions, just like we did right now. I'll post the link to register in the chat box in your GoToWebinar control panel, or you can go to go.blackspectacles.com/ARE-live to sign up. As I mentioned at the top of this webinar, Black Spectacles offers the first and only ARE pass guarantee. We're confident that if you use your expert membership to the fullest, you will pass the ARE. If you don't pass, we'll pay for your retake. To learn more about how to qualify for the guarantee, or just to check out individual membership options, head to go.blackspectacles.com, and I just shared the link to that to learn more about the guarantee in the chat. Don't forget to join Spectacular, the professional network for architecture and design. We built this platform for you to showcase your portfolio, seek inspiration, network with architects and firms outside of your local community, and help you find your dream job. Head to spectacular.design to create your free profile and upload your best project today for the opportunity to be featured on our homepage. I just shared the link to register in the chat as well. The lucky winner of our Black Spectacles t-shirt is Kay Abraham. We will reach out to you via email to get your size and shipping information. And if you'd like to be eligible to win a t-shirt, just post a question that you had about our feature topic in our community during our next ARE Live at community.blackspectacles.com. And don't forget, our community is always buzzing. It's not just during ARE Live, so please poke around and see what your fellow architects are up to and asking about. And I'm in there from time to time also answering questions. Just a reminder that this episode will be available in both podcast and video format after the airing. So to get the full experience, you can watch the video on our website, blackspectacles.com, then go to resources, and finally, ARE Live podcast. Finally, be sure to stick around for a few minutes to answer the questions in our survey and share suggestions you may have. I promise we read every word that you write and use them to fine-tune upcoming episodes. Thanks for watching.